Okay, very good. Welcome everyone. Thank you for coming out for CHA-Dev plus DevOps. I've got stickers that say that, CHA-Dev plus DevOps. They're right up here, so help yourself. We have CA with us tonight. I'll get to that here in a sec. We are, on a different Tuesday night this month because last week I had the opportunity to go to Atlanta and have dinner with, it was really kind of a small group. New Relic hosted Gene Kim, which is a name in the DevOps space. And he did a presentation, and it was pretty good. I enjoyed it. It was fun hanging out with folks. I got to talk to a couple ladies from Macy's, and they were talking about their journey in DevOps and what they were doing. So it was interesting. It was a nice networking opportunity. Next month, we're going to be back on schedule, and we'll be the second. I think we're the second Tuesday or the third Tuesday. Second. We're the second Tuesday because you're the third Monday, right? Yeah, exactly. We're the second Tuesday. We'll be back on schedule, and MongoDB is going to come in and do a presentation. And we might get a few more people because they apparently have some active accounts at some of the other big shops in town, and they're going to try and drum up some support for this. So hopefully it'll be a two-way street around. They'll get to present to folks, but they'll bring some more people in and introduce them to this group. So that's what I'm hoping for. And then in November, we'll probably go back to doing something of our own. I'm kind of cooking up some ideas, and I'll bounce that off some folks when we get closer. And then we'll decide about December what we're going to do, because that's always a tough month because of the holidays. Maybe we just go someplace and have pizza and beer and have fun night and not do a presentation that night. But we'll see. So this is all part of the CHA-Dev, plus DevOps. We've got the guy here who does the Python version of the CHA-Dev. Yep, that was last night. It was very good. I recommend it. And we've got CA here. We've got Ken and Ken from CA going to be presenting tonight. We'll hand that over to them in just a moment. And I wanted to mention that I thought it was interesting on Monday and Sunday, especially from a DevOps perspective, and to stop and think what may have been going on behind the scenes. And certainly Brett and I can associate with people running around with hair on fire in a big corporate setting, because both Amazon on Sunday had some problems around their Virginia center, and they blamed it on their hosted, their special NoSQL version of database at DynamoDB. They blamed it on that. And then Skype had issues all day Monday. So, and it's not unusual, and Brett and I certainly can resonate with it. Brett works at Unum with me, that this stuff happened over a weekend or on a Monday after a weekend, because that's when all the changes go in. And it's just, it's not uncommon at all to have issues on Monday. But even the big guys have, problems like that from time to time. So I thought that was interesting, and I thought about that from a DevOps perspective. So with that, let me introduce Ken from CA, and we'll get started. So you might want to actually gear up so you can do whatever.
I was going to hold up.
All right.
Hey there. Well, thank you guys for joining. The first thing I want to just mention, because I did hear that a few people didn't come because, it's CA. I've only been at CA a very short time. I've been a developer doing development consulting my whole career. Probably, if you'd asked me 3 years ago if I ever would have wound up at CA from my history, I'd have said never in a million years. But it's a very different company now than what people are accustomed to. We've made a lot of really cool investments in acquisitions we've done, and have bought the market leader in a lot of cool application development space. So let me progress this. So what we're recognizing, and I've personally recognized this for a long time, is that software is driving the world right now, and it's going to continue to do so for some time. So there's a lot of people, software's eating the world is a famous expression, right? And there's a lot of other spin-offs of that exact same thing. And so what CA is calling it is the application economy. Companies are having a really hard time keeping up with the pace of change. It takes large enterprises literally 18 months or more to go from a new idea to getting it out to a production. And it may not even be a new system. It may be just a modification to an existing system. Still takes them close to 2 years to get that to production. And that is just, with what, you guys can see it here, I guess with this innovative building and all the innovation and startups that are coming through this, how much faster you have to be in order to be responsive. And 18 months to 2 years is not going to cut it. So all the acquisitions that CA has been making is really geared towards this application economy. The one we're going to talk about the most today was an acquisition that happened a number of years ago, a company called ITKO. And they pioneered and invented a concept called service virtualization. There's been some other companies that have popped up since then. There's a whole marketplace now around it that Gartner measures and monitors. Oh, by the way, thank you. Okay. And so it's a really cool place to be. Very innovative, and I think it really is focused on what companies are really having a hard time dealing with in regards to just application development, software engineering, whatever you want to call it. All right, go on to the next one. So that was the marketing slide. We'll get past that quickly. But it's real, though. I mean, I am a big believer in it. As a result of this, businesses, most every large business has a digital transformation initiative. Some people even have a CDO, a chief digital officer to lead their digital transformations, right? That's not uncommon at all in large enterprises now. Go ahead and go through the animation. And so what we're doing, and what I'm going to do is I'm going to give you on the first 2 slides a little bit broader perspective around continuous delivery, so that if there's any other topics that interest you, we'd be more than happy to come back in and talk about any of those other topics. If they're not, then don't even bring it up, and we won't talk about them. But we're going to focus in on one of them today. But for this one, everything we're trying to do is developers have a lot of constraints that create them from developing quickly, and so we want to do things to help keep developers and testers from doing their job more quickly. Right now, developers sit on their hands more than they want to because they're waiting for somebody else to be ready, they're waiting for an environment to be ready, whatever the number, we'll get into more of that, but we help with that. Rapidly deploying code, it can be a very manual process in most places, and so they'll be done with their programming in 3 months, and it'll literally take 6 months. I mean, and that's not an abnormal thing to hear, that it takes them to take created code into production 6 months, when it only took them half that time or less to actually create the code. So those are other challenges that we are directly addressing, right? All right, so go on to the next one. So this is going to be that slide that kind of summarizes it. Animate it one time for me. So the first thing, and this will be what we go deeper in and what we're going to do a demonstration on today, is all about helping developers and really QA people as well and testers get out of gridlock. Right? Developers spend a lot more time waiting than they do working because maybe something they're developing, they want to do a quick unit test, but the things they need to integrate with aren't available yet. So they're waiting for another developer to be finished or ready, or they're waiting for another team. And in some instances, maybe another company they're developing a solution together and they're waiting for them to be ready. So we can address those issues. And that's the one we'll go to dive deeper into. Another issue is around test data. Sometimes, quality, one of the things, automated testing is a big deal, and we're certainly helping with that, and the solution that you'll see today also has test automation to it, and that's one aspect of quality. But the other aspect is the data, and what I'm finding in large enterprises more than anything, the reason they're not able to test properly is because they don't have the data they need. And so a lot of times, a lot of scenarios will go completely untested simply because they just don't have data that allows them to do that kind of test. Other issues, there was one company that I talked to, a major retailer, who said they had 7 full-time people that would spend 3 months creating data for a specific set of scenarios, that when the project teams were able to use it, it took them 3 months to create it, and then when the first team that used it would burn through the data, and so the second, third, and fourth, and fifth team that needed to use it couldn't use it because the data had already been burned through. So they spent 3 months of effort, 7 full-time people to create test data that had minimal benefit. So that's another real big problem, is that creating test data and things like that. So we have another acquisition that CA recently made. Is probably the most recent acquisition we made, was a company called Grid Tools. And it's a test data management solution that is really, really setting the pace for all the other tests. There's a lot of companies, like IBM has a solution. Informatica is big in that space, and 2 or 3 others. And all of them right now are trying to catch up to Grid Tools, which we just acquired, in terms of what they're doing, and now what I can say we are doing in the test data management space. So that's another really cool acquisition. And then the last one, have you gone through?
I got ahead of you, sorry.
Good, that's fine. You could tell this was created by a marketing person, all this animation, right? So, and then the other side of it is release automation, right? There's a lot of good solutions for doing specific things, like there's source control tools that help, and they do some automation. There's some build tools that help you, automate build scripting and things. And then there's configuration management that help you do configuration management. There's a number of good solutions in those different areas, but they're, This company we acquired, Nolio, about 3 to 4 years ago, was the first one that came out with a real release automation solution, which said, okay, how do we automate all of that stuff across the entire life cycle and work with, the Ansibles or the Chef and Puppets or the whatever it is, and all the different SCM tools and all the different tools. There's like 20 to 50 tools across that tool chain. How do we orchestrate all of those things to get a release out faster? So we have a solution called CA Release Automation, formerly Nolio, which is doing that. And really, at the end of the day, go ahead and go through the automation for me. That kind of describes all those constraints and all those issues that I was talking through, which we could talk another 30 minutes. Creates that wait time. Go ahead and fully animate it out now. And what these solutions that I described do is they enable parallel work streams. When I was talking about developers and testers can't do things in parallel, it accelerates quality initiatives, and then also end-to-end automation. Basically, the end of the day, we want to get from an idea to customer experience without all that wait time, and we want to do it much faster. 18 months, 24 months is not acceptable. We're at CA actually in our area. Our life cycles were pretty long when you compare it to like a startup, right? They were like, what were we, like 4 to 6 months maybe or so, and now we've gotten down to monthly, which is a big deal. And some of our customers aren't ready to absorb technology that often, but it's good that we can keep up with the market and come out with innovative ideas much faster. And that's really the goal of this, is help customers and people be more innovative, much more faster. Because right now, any company with any reasonable legacy has a really hard time with this, a really hard time. All right, so now I'm going to dive into the one that we're here to really talk about today, and that is service virtualization. So if you look at this, the top tier there is our different UIs that are available, and there's a whole number that we can rattle through. And the second tier are the innovative systems that we're building that need to be developed and also tested against. And then you might have an ESB there, and then a bunch of these back-end systems. Those back-end systems could be a mainframe, could be a third party, it could be something like Salesforce.com, could be, give me some other ones. Well, it could be homegrown, yeah, third-party things, all kinds of different things. And when you're having to test something you're doing, if you don't have access to these and you can't test what you're integrating with, how do you do a proper test? And as a result of that, the idea of unit testing, at least in large corporations that I've been working with, is for all intensive purposes dead. You just don't have an ability to do unit testing anymore. And what we're seeing is developers are just coding and then just saying, okay, deploying, and then it goes on through a large QA process. And they're hoping their code's good. But what's happening is all of the errors, which are, in many cases, very basic errors, defects, could be found much earlier, but they're not being found until 3-6 months after the code was developed. And then try finding out and debugging and figuring out where that error is when it's been 6 months have passed. It's much more expensive, much harder to do. So what we're trying to do is enable people to be able to do testing in the development, put testing back in the hands of developers so they can do early detection of errors and fix them when it's cheapest to fix them, and then let the QA specialists work on the true things that they were put there in place to do, and that is more edge testing, really hitting that application hard, making sure it works well with everything else, instead of just finding defects every time they touch a button, right? So it's all about providing this even when that may not be available. So let me give a few examples of why they're not available. Take Salesforce.com. A lot of companies use it. Salesforce charges for test environments. What they charge people, I don't know, but it could vary from customer to customer. It could be a very expensive thing. Take the mainframe. Mainframe has MIPS charges that go along with it. That could be very expensive to customers. And those types of environments may not be made available to developers or testers because of the cost, just the sheer cost. And therefore, you can't test things, right? So we can actually virtualize the mainframe or virtualize something like Salesforce or something like, where's some of the other ones that I'm just not, SAP is a big one. I'm trying to think of the big ones we deal with.
So in Unum, a couple candidates would be ServiceNow.
That's a perfect one.
Or Workday.
Workday, absolutely. And actually, we've talked to some folks about Workday. And actually, if let's say Workday was the center of the universe here, think about all the things Workday has to integrate with and how much trouble they have in having an environment for their testing. So that you can flip it, depending on where your perspective is, you can flip it so that Workday can do isolated testing without having to have all of the cost of this. Maybe it's licensing cost, maybe it's just infrastructure cost, maybe it's just the cost of the hardware, or the people to maintain it, or the data. Yeah.
So this is one of my favorite buzzwords, virtualizing. We're actually virtualizing the whole system anyway.
So what we're doing is it's more simulation. What we're doing is it's the request and response pairs that are the communication between it. So that's right. So think of it as, so what it is, it started off in its, think of mocks and stubs that developers do all the time. It's taking that, productizing the idea of mocks and stubs and making it enterprise scale, right? So that, it's not just the developer who created the mock or stub that knows how to use it and then continually has to update it, right? But you can do it so it can be shared, reused. There's a model that's behind it that you can make it much more easily maintainable. A number of things to make it enterprise scale and much faster to create than actually hand coding a mock or a stub. But that's precisely what it is. And we'll get into more of that, and you'll get to see that, how that actually works. I'm trying to think of some other examples for you so you can get creative, because the cool thing about this is once you understand this technology, every customer I talk to comes up with a different way to apply it. So I was talking to somebody at Unum recently who's on the DR team, and he's like, the problem we have when we're doing like web service testing and for disaster recovery, all the other things that this web service integrates with in the DR environment are not available. So how can I do that? So what do? They don't test it. They wait 3 months, 2 months, whatever, and then they do it, right? So what we're talking to them about now is, okay, what if we created, when they were available, we did a recording of it and, took the request and response pairs, and we made it available so that you could do it. You do your DR testing day one. Another classic example of this is take a company like Sprint and a company like Apple. They're launching the iPhone for the first time a number of years ago. They both have to do major development initiatives for that launch. Major, right? And they have to test against each other. But think about development projects. Once we set our end date, the end date was set before we even scoped what was needed to be built, right? It was set by market pressures, whatever the pressures were for that project. Every project has its pressures, right? And they all are just going to say, okay, they're marching to that date, and they magically can create project schedules that map to that date. Well, guess what? They both get to that date at the same time, but they didn't test against each other. Their stuff has to work together. And they had no mechanism to do that because they were both building in parallel, right? And that's what I talked about earlier about building, enabling parallel development. So what they could do is create virtual services of each other. And then they could be testing much earlier. I'll give you a good example. Auto Trader is a big customer of ours. They had three test cycles, 1, 2, and 3. They were finding anywhere up to 38% of their defects were being found in the last testing cycle, right before deploying to production. It's not a good thing. That does not give you high confidence, and you are certainly going to have defect slippage into production. And not to mention that the later you find it, the more expensive it is to fix it. And that was they had metrics, and for well over a year of releases, they captured like 6 or 7 of the last ones, and it was 25%, 38%, 18% defects being found in that last stage. They implemented service virtualization. The next 3, 0 defects were found, all because it enabled developers to actually do real testing early on. So go on to the next slide. Now I'm going to hammer think about it. If you have one little component, but it really operates in a much bigger world, wouldn't it be great if we could say some of the UI components weren't available? They were being built in parallel, right? Back-end systems that it has to integrate with aren't available. Just go ahead and click it. And so it's actually not even called CA Lisa. So when it was ITKO, it was ITKO Lisa. Now it's CA, then it became CA Lisa. And now this year it's called CA Dev Test, because it's a solution that's tailored for development and testing. So we can actually stand in place and drive the test, and we can also stand in for the back-end systems, allowing you to take what you think of just this little, small component and actually do some real exhaustive testing with it so that you can really get the quality of this up. And I'm trying to think if I want to go back to the other slide, but maybe not. All right, so that was all. I tried to keep it short. But let's stop for a second before I turn it over. What other questions do you have? I mean, you guys think of any other creative ideas? I mean, I can rattle off some other customer experiences and.
Not necessarily exactly that thing, but on your previous slide, you were talking about a Lisa product. It was something you guys acquired.
Mm-hmm.
Did you tell me on our lunch a couple weeks ago that that was actually the company name?
Well, so I don't know that anyone knows the real story. So Lisa,
There's several stories.
I can tell you a few. They're kind of funny. So Lisa, people always ask me, what does Lisa stand for? And the story I heard first was that it was the founder's girlfriend. Was her name. Whether or not he had a wife, I'm not sure, and I didn't get that side of the story. But but that was always what was joked. But apparently, I think then I heard it was listen, inspect, simulate, and analyze. It sounded like that acronym maybe was thought of later, or that meaning for the acronym was.
I've never heard that. That's interesting.
Yeah. So what did you hear something different from those two?
No, it was like the founder's daughter or niece or something.
Yeah. So another good example. One of my other customers that I support, in addition to Unum and Blue Cross here in Chattanooga, I support FedEx, and they were an early adopter of this technology a number of years ago. And they create. If you think about FedEx, they care as much about their UI and their digital experience for customers as anybody. But what they really care even maybe a little bit more about is how companies can integrate with them. Because if you think about all the different small companies and big companies that have to have shipping needs, and on their website they want somebody to have the ability to ship whatever it is they're doing. My wife was a Python developer for a real estate investment company. And she was having to develop a web page that integrated and allowed somebody to ship, so she was having to consume and use FedEx web services. And she was having to, figure out how to test against that, and she was having a bear of a time doing it. And one of FedEx's challenges is, well, how do we, all that marketplace that wants to integrate with us, how do we get them to test against our stuff without it being too expensive to them? Because we don't want them to be expensive for them, because we want them to come to us instead of UPS or someone else. Right? And how do we do it and make sure that the quality of what people are using, is high so that we don't inadvertently get a bad name for ourselves through some other third party, right? So what they created, and was the first usage they did with service virtualization, was they created FedEx in a box. They basically created the virtual services that say, look, if you're going to integrate with us in this way, here's some virtual services that emulates our environment that you're going to have to work with. Take it, test against it, and then when you've reached there, then come to us, and then you can work through our process of, getting certified. And so there's been a lot of customers that have done whatever in a box, right? So there's a lot of, we have customers that are, the credit card companies charge transaction fees. PayPal, if you want to integrate with PayPal, they charge transaction fees for testing. The first 6 per month are free, and they charge some amount for every transaction after that. Well, we could create a virtual service for PayPal, and then you don't have to pay PayPal every time you want to do a test transaction, right? So it's a lot of saving money, speeding up time. Yeah.
So doing a lot of PayPal and systems integration, if you should more than 6 test transactions with PayPal, you should be slapped anyway. It's a brain-dead, simple, beautiful API. If it's taking somebody more than 20 or 30 calls to PayPal to do it, they need to be slapped. I'm sorry.
Well, okay.
It may not be just the PayPal interface. It may be, that's one thing that it does in the context of a larger transaction.
Yeah, no, I've moved millions through PayPal. I mean, literally. And it's a beautiful, simple API.
And what I'm saying is not just the PayPal interface.
Right.
It's a large, complex transaction that you don't want to, if you're testing 10,000 of these transactions, you don't want to be making 10,000 calls to PayPal because you're going to be paid for the test. So by virtualizing just that one thing, then the system under test, if you're testing all the rest of the operation of it, you're not incurring 10,000 calls into PayPal. That's really,
I'll give you that one.
but that's really what.
Yeah, it's not for the testing of the PayPal, it's for the bigger overall.
Yeah, because the system under test is your transaction that you're testing, that you're trying to make sure works right. And one of the 25 things that it does is maybe says, okay, at the end, after everything else is cool, I'll go to PayPal.
And that's actually an important point. It's really about what's the system under test.
Yeah.
In my scenario, PayPal is not the system under test.
It's the bigger thing.
Yeah, yeah.
It's just one thing that the system under test is calling, you know.
So, all right. Well, with that, any questions? Any other comments, questions? And then I'll turn it over to you guys. Want to see this? See? All right. Let's go.
Just skipped all that and shown it to us.
Yeah.
Well,
I've been waiting.
I paid for the pizza, though. Come on.
He did. He did pay for the pizza. Okay, I'm not holding that because I got a type, so I can't.
Okay.
I don't know how you handle encrypted variable data.
Here, this is. You can lay that there.
I'm gonna do this.
So while he's getting ready to.
Testing, 1, 2, 3. Does that work?
You can slip this in your pocket.
Yeah.
That way you can get up and walk around.
Yeah. I don't need to do that now. I'll do that. I'll do this. That way I don't have to deal with it. Is this still working? Okay. How we handle what?
Well, most of the systems I talk to are
Encrypted. Okay. Sorry, I can't hear you.
yeah, in the state,
Yeah.
state systems under test. So I don't see how.
Yeah. Well, I can't really show you encryption because I got to have an encrypted system to go to, but we support SSL. You know, we support HTTPS on transactions. So, you know, all you have to have is a certificate, and we support two-way, mutual. Yeah, when we're recording, we're a proxy or a gateway in the middle. Yeah. Yeah, and I'll show you that. Oh, well, that's not going to work, is it?
What if you square up on it? We can see it on your.
How about this? All right, so why is that still there? Let's get rid of that. Get rid of that. Get rid of all this stuff. Oh my God, this is not a whole lot of real estate to work with, guys. So it's going to be hard to show you a whole lot.
You should be able to match change the resolution and I'll scale it.
The resolution's coming from that thing because it's scaling down to that.
This, like, if you try changing it.
You can change it on your laptop.
Yeah.
Let me just.
It'll just scale everything down.
Why did it scale down so much? Because this is like.
Windows starts low and goes high, everything else starts high and goes low.
Yeah, there you go.
800 by 600. Wow. I can't even get to the part of the screen that it says okay.
Yeah. Maybe hit enter. Scroll down.
There you go. Apply. Come on. Please work. Much better. Much better. Okay. Whew. Starting to panic.
It's a little small. Can you make it bigger?
I haven't seen 8. No, I can't. Because then I won't have any screen real estate to work with. It's not even the full resolution yet. It wouldn't even go up to the full resolution of this thing. But that's okay. Okay, so now I have to start up some stuff. Or is this already running? Okay, this is already running. This is this little server running in the background is a JBoss server, and it's got a Apache Derby database that it's storing transactions in. And basically, it's a server that acts like a bank. It services transactions for ATMs and stuff. Okay, so what I'm going to do here, and I've got this other. Wow, it moved everything around on me. Okay, so that guy is just going to run in the background. We don't need to watch him. It moved everything around on me, so I don't know where my icons are now. This is a Windows app. That looks like a kiosk, and it runs like a kiosk. Okay, and I can change like the host that it's going to, and
This server over here is running, well, not this server, but the JBoss server that I had up here before, that I minimized, is running on port 8080 on the local host. So I configure my financial kiosk application to talk to that back-end server on port 8080. And so when I log in, and I'll choose this user called Lisa Simpson. When I log in, it's talking to that back-end JBoss server. And if you don't believe that, I can bring up this demo server, and you can see it doing stuff in its little window here. So if I look at the checking account, I see that, well, I do a statement. It has an initial deposit of $1,000, and you saw this guy do some things, because this JBoss server is servicing the calls that this front-end application is making. Everybody got that? Because that's been a point of confusion sometimes when I show this to people. They're like, what's calling what? So I can do things like, look at the balance. It's $1,000. I can do a withdrawal if I want, which is, let's say, $40. And this guy processed that into the database that's built into this little JBoss server. So I do another transaction. Maybe I do a deposit of, $100. And I do another transaction, and I look at the statement. Now all those things are on the statement, and it gave me a $5 first withdrawal promotion here. So this is what the server's doing. These are HTTP transactions, encrypted, that are flowing back and forth between the client and the server. So what I'm going to do now is log out of this, and then I'm going to start up. DevTest, by the way, is running in the background. My DevTest server it's just Windows services, and I'll show you these just so you know what they are. There's several of them. There's the registry, which, oops, I don't want to do that. There's the registry, which is kind of the heart of the system. It keeps track of like if your license is valid and all that kind of stuff. And then there's the enterprise dashboard that kind of keeps track of the whole system. And then there are a whole bunch of other services here. A broker is one that different parts of the system communicate with each other by sending the broker messages and stuff. And then there's the portal, which is the user interface that I'll show you in a minute, that you use to record and display things. And then there's a simulator, which runs simulated. If you're running a big load into a system under test using the test side of DevTest, which was that over on the left on your slide, where you can have a whole lot of test cases and run them in suites of test cases and run them, n number of times this fast, that kind of thing, to really hammer on an application that you're testing and do not just functional testing, but load testing as well. The simulator does this, and each simulator instance can handle 250 what we call virtual users, which are things that are generating load into an application under test. And then the VSE, which stands for Virtual Service Environment, that's where all of the virtual services that you've built run, and you can have multiple of those as well. And I'm going to build a virtual service in a minute. So these are all the DevTest things that are running in the background on my workstation.
So you're running on your Windows workstation. Does it run on other platforms?
Yeah, runs on Unix, all flavors of Unix. Runs on Mac native. Of course, not many people run DevTest servers on Mac, but you can. What else does it run on? Those are the big three, really. Yeah, Linux. Probably most of our customers run either Linux or Windows, and I'm not sure what the mix is, but it's 100%. It's all Java code, so it's 100% the same on Unix or Windows. Did you have a question?
Is this the normal use case that you would run on a developer workstation, or would you have a central server?
Normally you have a central server or set of servers.
Actually, no. So let me come over here and talk to that, because that's an interesting, there's more to that question, I think. So originally, we used to license this thing by server. And what happened is the server had a high ticket cost to it. And so by default, customers are like, well, let me avoid cost, let me centralize this. And, QA is using it, so let's centralize it in QA. And what would happen then, developers would want a virtual service for something that they were developing early on, and they wanted to quit virtual service for something, but guess what they had to do? They had to go to the central team. And then what happened? Service virtualization became the bottleneck. What are we trying to do with this product? We're trying to eliminate constraints, eliminate bottlenecks. So we got rid of that licensing model, and now we only license per user, and now you can have as many virtual server environments as you want at no extra cost. So for that reason, I think there's certain things you're going to want to have centralized, right? So maybe common virtual services that can be used widely, but you really want to, in my opinion, you want to federate this out and give a mobile development team like yours the ability to have their own virtual service environment, whether you put it on each developer's desktop or you have your own little server for your team, you guys decide, right? But you need to have the freedom to create a virtual service quickly and not be held captive by a centralized environment that may have bureaucracy wrapped around it. Because if you do that, then you're going to defeat the purpose of the solution. So, and that's why we changed our licensing model, was so that we can get away from becoming the bottleneck. So, does that help?
Yes.
Okay.
Okay. But technically, you can do it in any way you want, because there are things called power users, which have the ability to create virtual services and run high volume tests and things. And then there are, runtime users, which can use virtual services, deploy them under their own environment that were built by other people, but they can't build virtual services themselves. So the licensing model is kind of, there's two kinds of users. And then there are also power users that are, if you have very high load test requirements where you need to run, thousands of transactions per second, through the system, and you need some virtual services on the back end to simulate these, back end systems that your system under test is calling. Those virtual services need to be able to sustain very high transaction rates because your system under test is itself being tested by the tester sitting over here pounding it. And so it's going to be, because it's having to respond to all these requests that are coming into it for stress testing, it's going to be pounding on its virtual back-end services. And those virtual back-end services need to be able to handle the high transaction rates that are being sent to them. So we have a thing called a performance VSE that is another type of licensing it's really the same code. There's no code change. It's just that performance VSE license allows you to handle more than 10 concurrent transactions in the virtual service. So it's kind of limited in the standard because it's more based on functional testing, not performance testing. But if you're doing high stress performance testing, then you can license the VSE to be a performance VSE. Then that restriction of 10 concurrent transactions is removed, and the VSE will run, to the limits of the hardware and the memory that it's running on. Does that make sense? Okay. Okay, so where was I? Okay, I showed you the services. Now, there's there still is. There's a thing called the workstation that doesn't look like that. That's the portal. It looks like, as soon as it comes up, it looks like it's loading a lot of code. It looks like this. Okay, this is the dev test workstation. It's kind of like an Eclipse. Think about it like an Eclipse. It's a GUI IDE. It runs on Windows or on Linux machines or on Mac. And basically, it allows you to have projects kind of like Eclipse does, or what's the other IDE that a lot of people use now? It's kind of like for the .NET environment, yeah. What? Yeah, NetBeans. Yeah, which is actually down here, but I'm not going to crank it up. And there are several others, but I mean, Eclipse and NetBeans are real widely used, especially for Java. And yes, Visual Studio is used for .NET. I've used that in past lives as well. .NET's a whole different deal. We can talk about that later in terms of getting into .NET CLRs and stuff. They're kind of walled environments where it's hard to get in there with agents and things like we can with Java. But so this is just an example of a project. Here is here's a virtual. Oops. No, sorry, can't do that one. Anyway, this is a project, and this is the workstation that we used to have to use to do any kind of recording or anything. What they're doing now is moving away from the big GUI OS-specific environment and moving towards a web environment. So the way, over time, you'll see more and more functionality of the product be implemented in this web-based portal, so you won't have to have really anything installed on a developer's workstation. They'll be able to do everything, and that gets in the server versus developer workstation. You still have to have the proper licensing, but we're moving to an environment where we don't really have to install a bunch of code on your developer workstation. That code can run up on a server, and then you can build your virtual services, you can do your recording, you can manage them, you can deploy them, all of those kind of things through a web interface, so you don't have to have a big honking bunch of code installed on your development workstation. But you still get all the management functionality of a centralized server. Because, for example, in the old world where everything was installed on your workstation, if you did a virtual service recording, that recording existed only on your workstation. Well, now in the portal environment, and I'm going to do this, if I say create a virtual service, I'm talking to the server, which in my implementation is running right here on my laptop, but it would generally be running on some big server somewhere, right? So when I make this recording, that recording is stored up on the server, and it's visible to anyone who has the rights to see it. And they can deploy it into their virtual service environment if they have a different one. So there's a lot of centralized management and resource sharing and things like that come with operating in a web-based shared kind of environment versus everybody having a whole bunch of code just on their workstation.
So are you going to show us how to use this tool to emulate the ATM app? Is that what we're headed? Okay.
Mm-hmm. Yeah. Okay, so this is, I'm going to make a recording now. And I've only got one VSE on my machine, virtual service environment, which was that service I showed you earlier. So let's name this Cha Dev Ops. How about that? And then I'm going to go down here. And since the portal is kind of new, it came out in Release 8 last year. The only thing it really supports right now, we can virtualize a website using HTTP or HTTPS, which we're going to do now. We can virtualize JDBC calls, so you can virtualize database operations. And you can virtualize, using a COBOL copybook, if anybody, does anybody know what a COBOL copybook is here?
I know what it is. I've never done one.
I was going to say, you guys are old enough. I grew up with them because I grew up in IBM. It's a way of representing data structures in COBOL, which was a language that used to be used and still is on mainframes, but probably most of you haven't ever dealt with it. So that's one thing. And then you can virtualize using request response pairs. So if you can capture, or just mock them up, here's an HTTP request, here's a REST request, here's a SOAP request, whatever, XML request, and then here's the response for it. We can create virtual services from those request response file pairs as well. So that's another way to create virtual services. But what we're going to do here is create it using HTTP, because that's what this client server application, this ATM application uses to talk to its server. So, and we can use SSL if we want. And I can specify what port. It generates a default port, which is unique to every recording session, but I like to change it to the one I want to use so I don't have to remember all these different ports as I do these things. So I'm going to record on port 8070, and I'm going to set my ATM client to talk to its server on port 8070 in a minute. And then the target URL, which is my back-end server that I'm going to pass the request to as I record them, is colon 8080. And see that went green? Because what it did when I typed that in, it made a request. And if it got an answer from a server, then it says, my server's there, so we can proceed. If it wasn't, then it would stay yellow or even red if it wasn't a valid host name or something like that. So since it went green, everything is fine. So I'm just going to start my recorder now. Now I'm going to go back here to my kiosk, and I'm going to tell it, don't talk to 8080 where the back-end server is. Talk on port 8070, which is where my recorder is running. Okay? So what this thing is going to do now, and let me refresh. Now, see I got a transaction here in my recorder? Because when I refreshed this, it went and pinged the 8070 server, which is my recorder. So now this front end is talking to my recorder. My recorder is going to record every request, pass it to the back end application. Whatever response comes from that back end application, it's going to capture that response, and then it's going to create what we call a transaction, and it's going to put that object into the virtual service image that we're recording. And you can let a recorder run for a long time and capture hundreds or thousands or tens of thousands of transactions, each of which is a request and a response. They can also be stateless, or they can be stateful. So you can have chains of requests that have to be in a conversation, a logical conversation. So in other words, you have to log on before you can do a transfer, et cetera.
So the JBoss app is still running on 8080,
Mm-hmm.
but the recorder's running on 8070,
Mm-hmm.
and this dashboard thing's in between.
Right.
The browser and the JBoss, intercepting those calls, routing through, recording what comes back, what goes out.
Yep.
And the whole idea is when we're done, then we're going to be able to talk just to the virtualized service.
Yes.
Turn off the JBoss service.
Exactly. So we call that virtualizing a server or virtualizing an application. And it really is about that simple for things like HTTPS. Now you get into things like JMS where you have complex message flows and asynchronous message flows. It gets a little more complex, but we can record those things too. But most of the, probably, well, I don't know what the percentage would be, but the vast majority of web traffic's all HTTP, right? And a lot of the communication between applications in enterprises is HTTP versus JMS or TCP sessions or something like that. So HTTP is almost ubiquitous, although there are JMS. JMS is very widely used for applications to talk to each other as well. But and we support all those different protocols, just not in the portal yet. We still have to use the workstation program to record things like JMS, but over time, those functions will be put into the portal as that code's moved from the old Windows or Unix GUI environment to the web environment, okay? So, what I'm gonna do now is log in as Lisa Simpson. And you'll see this over here the number will start going up as it captures these transactions. See, then once you just went to 2. So I'll say checking. I'll look at my statement. There it is. Now, interesting thing here, I'm capturing this, right? So I captured the statement request and I captured the response, and the response had this data in it. Right now, this response has this data in it. So if later when we actually run with the virtual service, you're going to get this data back, okay? Unless I do it again, then you'll get more data. So it's recording right now, and the data responses that it gets during the recording are what goes into the virtual service image. So that's what it's going to play back when you use the virtual service later. It's not a real application, right? So it doesn't compute things.
Do you have a place to insert logic into
Yes.
this data variables? Okay.
Yeah, it's extensible. There are lots of extension points that you can add to it, but just recording something,
Right.
when I say statement against the virtual service, you're going to get this.
Insert a variable into that data.
Yeah, In fact, you can even, we have, it's called data-driven virtual services, and you can set up the virtual service to go against databases. So it can really start acting like a real service would. So it can say, here's an account ID, go against this database table or this Excel spreadsheet and give me the current data based on accessing some table using that key, for example, and give me these columns out of the database back so to put in my response. So you can make this responses very dynamic. It's more work than just straight recording.
Right, but it's more real world.
It's more real world.
Yeah.
Absolutely.
Well, the recording feels like a framework. You're developing a framework.
Yeah.
You gotta flesh it out to fit the real world.
Yeah, yeah, and I've done quite a bit of work in developing more dynamic or real world or types of applications where you're not just sending back a response, but some of it's automatic, and I'll show you that as we move on here. It's not all hardwired. So for example, when I do a balance, there's the current balance. If I do a deposit of $40. Now here it says your deposit of, and it echoed back what was in the request. That's called a magic string. So if the same data element is in the request and the response, the virtual service at playback time will echo back whatever came in on the response.
If it sees the same variable.
Yeah. So if I just recorded one at 40, but when we play it back, I'll say make a deposit of 100, and the virtual service will come back and said you just deposited $100. So it's not hardwired into what I recorded. That's called we call it a magic string. And then here's a magic date. Funds will be available. This is exactly 72 hours from right now. So, and it recorded that, but it has a thing called a magic string, which is a function that does a date delta from the current time. So this date delta was exactly 72 hours from the current time. When I play it back, it will compute the date delta from the time of that transaction. So it won't be this date, it'll be a date that's 72 hours from whatever date I call the virtual service to make the deposit.
You have to tell it what format the data is, does it understand?
It just understands it. It sees that as a date and says, oh, I'm going to make a magic date out of this. And it does that by, well, there's some magic. That's why we call them magic dates and magic strings. The code looks at these things and it sees, oh, this is a date. So I'm going to treat that, I'm going to make a magic date out of it, so it will always have the same offset from the current time as it did when I recorded it. So yeah. So magic strings and magic dates aren't really magic, but they're pretty darn nice to give you dynamic data back. And then I'll do a withdrawal of, let's say, $10, just so that transaction type, that operation, that SOAP operation, makes it into my virtual service image. And I think that's all we need to do. So I've recorded 7 transactions, and I'll say stop recording. And then I will say next. And now there are things called data protocols and there are things called transport protocols in the product. Transport protocols are things like HTTP, TCP, JMS. They're protocols that are used to transport data from one place to another. Data protocols are things that are used to identify and handle types of data like SOAP or XML or REST or other data level protocols. And those are 2 separate things in DevTest. You can run SOAP over JMS. You can run SOAP over HTTP. You can run XML over HTTP. You can run XML over TCP or XML over JMS. So they're two different levels that really don't have anything to do with each other, but it's very flexible to treat them as 2 separate things because they really are. So this is SOAP, and it saw it when these requests come in. It looks at them, and it says, "Oh, this is a SOAP request." So I'm automatically going to put the SOAP data protocol handler in here for you. You don't have to do that. But there are other response data protocols that you might want to put on. If you had some JSON data going back in a response, which is kind of weird, but you could do that. You might have to add the JSON if you have some embedded JSON, or if you wanted to zip up some XML, you could add the zip data protocol handler, so it'll take the XML response, zip it up, so there are things that you can do, but we're not going to do any of those. So we'll say next, and you can allow duplicates or not. If you don't allow duplicates, it'll strip off any duplicates and only put the unique transactions into the image, which makes it smaller. And then we will say, let me go down here, and we will say save. Okay, so that's saved. We've just created a virtual service. And if I hadn't been talking so much, it would have been a lot faster to create that. But now we go to manage all resources, and we'll see that virtual service, Cha DevOps. And what I want to do, no, not here. You can look at it and see, you know, all the different transactions and what they look like, and the request and response data, because all the raw request is saved in the virtual service image. But what I want to do, and I can't remember how to do this because I haven't I haven't been working with the portal that much. I think it's right here. Yeah, deploy. This is totally different than the way we used to do it in the workstation, so I'm used to doing it in the workstation. So if I say deploy now, I can give it whatever concurrent capacity I want it to have. This think time is kind of interesting because all those transactions that we recorded, it recorded the response time from the server in milliseconds, and it put it into every single transaction. So if the server was really slow on a transaction and took, 2.5 seconds, it would put 2,500 milliseconds as the think time for that one transaction. So when you call it, the virtual service will wait for 200 or 2,500 milliseconds before it gives you the response, because that's what the real system did.
Simulates expected load.
Yeah, and you can change those individually because it's just a field in that request response pair. So you can change it to whatever you want. You can change it from 2,500 to 3 if you want, or 100 milliseconds, however you want it to work, or 0 if you don't want the virtual service to wait at all. But you can also, when you deploy it, you can say use a think time scale %. So 100% means use exactly what was recorded. 50% means make it run twice as fast as what was recorded, so cut each response time in half. 200% says double each response time, make it twice as slow as the real server was. So you can change that right here when if you can say 0, don't use any response times at all and respond immediately. And a lot of times in functional testing, you want to do that because you don't want, if your server was really slow when you created the recording, you don't want to have your developers waiting 3 seconds just because the server was bogged down that day when you made the recording. So you can say set this think time to 0 or 10, and it will wait, for a very short period of time or not at all. So when your developers are doing their functional testing and going against virtual services, the virtual service responds instantly instead of waiting 3 seconds like it did during the recording.
So when you set that to 0, I guess you could call that the VW response time.
Yeah. You can do a lot of stuff with. You can do a lot of stuff in software, man, if you know what you're doing.
Oh, yeah.
That's now spread to Korea. I was hearing as I went up, it's like every country in the world is going, what's going on, guys? So
And they're just the first car manufacturer to get caught.
Oh, others have done that. Their stock was off like 17% today, in one day.
I thought I saw 23.
It may have been higher by the time the market closed. This was when I was driving up here earlier. So yeah, it's pretty ugly. So anyway, I'm going to deploy this. And that's all I have to do. It's deployed. Now, if I go to this other thing called the DevTest console, which is a web-based console that shows you the status of all your running processes, this is going to get moved into the portal over time too. So the portal is going to kind of be your one-stop shopping interface to all this stuff. But this DevTest console has been around for quite some time. It predates the portal. So it's still a separate web thing right now. this kind of just shows you your environment. I've got my registry with one coordinator, one simulator, and one VSE. So I'm going to go look at the VSE, and there's my CHA DevOps that I just deployed. It's running on port 8070, which is the same port that I was recording on, right? So now if I go to my kiosk, it is still set to 8070 because it was talking to the recorder. Now it's going to be talking to the real virtual service that's running on that port 8070. Now what I'm going to do is I'm going to go kill this demo server just so you believe that we're really talking to a virtual service and not still talking to our demo server. So that demo server is gone. He's not there anymore. So when I log in now as Lisa Simpson, it doesn't really matter what I put in as the password because this is a virtual service. It's not going to check my password against anything, right? So I can put XXX and it'll work. Okay, now notice from the application's point of view, it's responding, and see this data is what we recorded, okay? It's responding exactly like the real server responded. So the application does not know it's talking to a virtual server now. It's just making HTTP calls with SOAP data in them, and it's getting a response from that endpoint. So here's the balance. Here's where I make a deposit, and I say, let's deposit $100 now. And it says your deposit of $100. And this is exactly, well, it's actually, it's 72 hours minus like 4 minutes. But it's not 708 or 7 whatever it was before. This is a dynamically adjusted value. And this is a dynamically adjusted value. And it does that automatically for everything. So if you have a big, huge request with lots of data structures in it and lots of fields and elements and things, and you have a request coming back with lots of structures and lots of elements, any of them that are named the same will get copied from the request right into the response automatically. So it's not something you have to say, I want this field done, I want this field done. It does it for all of them. Now you can go into the image and turn that off if you want. But the default is make magic strings and magic dates out of everything, because that's normally what you want. You know, you want the response to come back echoing the same data that came in on the request if there's data that's echoed, right? It's kind of normally what you'd want, so that's the default. And then, so we do a withdrawal, let's say, I don't know, $10. Now in the response it says $10 comes back in the response. So a virtual service mimics a real service, but it does it by responding with the same responses that the real service would respond with, without having to go, through all the logic that the real service executes. So they're very lightweight. In fact, a virtual service and the corresponding what we call a virtual service model, which is just kind of a series of steps that get executed to actually make this happen, they're just tiny little XML files. And they get deployed into a virtual service environment. The virtual service environment. Has anybody ever worked with middleware like Tibco or Web Methods? Those kind of things. They basically do the same thing, where you have a workflow is just an XML file, and there's XML elements that say here's a step, and then here's a bunch of properties and data that govern this step. And the little XML file gets sucked into the virtual service environment, and those steps get executed by calling various Java methods under the covers. So you can think of it as like the XML that gets generated for a virtual service model, and then the virtual service image that model uses to contain all these requests and responses. That's just data that gets put into the virtual service environment, and things happen based upon the contents of those XML files. So I guess the point is, there's not really code that's being generated here. It's just a bunch of XML files that tell the virtual service engine what to do when it gets a request of this type on this port. Here's what you do with it. Go out and look in the virtual service image, find the correlating response to this request, adjust all the data values, and then hand it back. So that's really what virtual services do. They mimic real services, but they're very, very lightweight. You can run hundreds of virtual services in a virtual service environment, which is just a JVM, because they're just tiny little XML files that get pulled into the JVM and stored as data in the virtual service environment. So they don't take up much space. They're very fast. They're very lightweight. They don't take a lot of memory. Think of virtualizing a big application like an ERP system like SAP or a CRM system like Siebel. Those things are enormous, you know? But all we really care about is what's the request that went in? What's the response that came out? That's what we're going to virtualize. So all these hundreds of request types that go in and the responses that come out, that's all that's in the virtual service image. It's just the requests and the responses. So all that SAP code that would be running in a development environment isn't there. The only thing that's running is this small, lightweight little virtual service, which is really just an XML file that gets loaded into a virtual service environment. And every time it gets a request on a certain port, it'll give you this response back, just like SAP did without having to have SAP there. So you can run lots and lots of really big application virtual services that behave just like those big, huge applications without having to have an instance of that big, huge application in that development environment. And that's where the real power of this thing is being able to allow developers, whatever your application is calling, whether you're calling another Teams code, whether you're calling into SAP, whether you're calling out to PayPal or Amazon or whatever, by virtualizing all those interfaces that your code is calling out to, now your code can just call out to virtualized instances of those, because you don't really care about the application you're calling. What you really care about is, here's the data I'm feeding you in the request, and here's what you responded with. And then whatever your application does with that response, that's what you're testing. You're testing your code, right? So by virtualizing all those back ends, you don't have to worry about, well, I didn't get an answer, or I got, a bad response because they're, whatever the part of their system that handles my response wasn't up, so I got an error back. Now you do need to test, all your error handling and stuff, and you can do that in virtual services as well, because you can take not only the happy path, but all the unhappy paths that result in errors. You can actually cut and paste requests and responses in the virtual service image and build it up. And you can set error conditions that say, if I send you this request with a certain customer ID in it, I want you to send me back a SOAP fault with this error information in it, or some kind of an error structure that says that's not valid. So you can build those kind of things into your virtual service so it can handle all those different edge cases, so you can make sure your code works right when you get errors back. Because error handling is a big part of writing good code, right? It's not all happy path.
So now I've got this set up and it's, emulating a service, and now I can test without testing against the actual service. So is there a facility here to let me analyze what I'm doing or what's being done to it so that it can help me debug my code? I mean, I'm testing my code. Let's say something didn't go right. I want to look at the traffic. I want to see what my code sent to this server. Is there a way to analyze that?
We'll send a response.
There's
No, it does. No, not really. It doesn't. A virtual service, once it's up and running in a VSE, it just, if it gets this response, it's going to give you this request back.
It's not logging what's receiving and sending?
You can log it. It's a lot. There's overhead involved in doing that, but yeah, you can cause it to log the request and the response, the actual raw text, the bytes that it's getting. You can have it put that in a log file. Not a lot of people use that though, because
I do all day, every day. This is half of what I do for a living, is emulate things that I've sniffed the traffic for, write simulations for, and use Snippet to watch the traffic. Because I'm testing against systems that only exist one place in the whole world, and it's,
okay.
I never really
Then
get your headache.
Okay, well, that might be very useful for you then. Yeah, but it'll put into its log this service, this virtual service, this operation was invoked at this time, and here's the data that came in, and here's the data that went back out. It does that.
Yeah, well, I was going to add one thing, and you can correct me.
Sure.
Because I'm going in a different path here. But for the most part, when you're using what we're kind of describing right now, we're talking about very isolated testing. So you're testing you're not testing the whole, you're testing this isolation, so you don't really care, and you don't want to care. Right? 'Cause
But
we're
you
stressing
can,
this.
though. I mean,
No, but so
virtual
where I'm going
services
is-
can be put into different places
So
in a very large integration test.
Right, but where I'm going is CAI, that we never really
Yeah.
talked about.
Yeah.
And the fact
I was going to get there.
Oh, do you want? I'll let you do that. Okay.
There's another part of this product that we don't tend to lead with, but it's an extremely powerful part of the product. It used to be called Pathfinder, and now it's called Continuous Application Insight. It's built into the product. You need separate licensing to actually run it. What it does is it puts a Java agent in any of the most popular platforms like IBM WebSphere, Oracle WebLogic, JBoss, not .NET, and that's one of the things about .NET. It's very difficult to put things like agents into .NET because the common language runtime is not open like Java is, and you can't easily intercept things in .NET and reroute them and stuff because the CLR does that kind of stuff for you. So you can, but it's not a trivial thing to write agents that go into .NET environments. So we don't have an agent that goes into .NET environments. But for all the standard Java platforms like WebSphere and WebLogic and JBoss and what are some of the others? Well, just plain old Java. We've got agents that you can put into the JVM, and you install them very easily. There's a command line interface to do that. And what it does is that becomes your endpoint, and then anything that comes into that endpoint, it routes that to wherever it needs to go in the application machine, and then it captures all the responses coming back. So that's a much deeper, more introspective level of virtualizing traffic within a system. But what it can do is it'll construct a very detailed map of exactly what's going on in that Java-based system, what's calling what. Here's a service that got called. It called this other service. It did a JDBC operation. It put a JMS message on a queue. It tracks all of that stuff and reports it all back. So some customers have actually used CAI to document existing system behaviors because they don't have documentation for these things, I mean, it captures things like the actual SQL statement and the actual compiled SQL statement. So here's the SQL statement, and here's what it actually compiled to, which is very cool because dynamic SQL it's just a string of SQL, but when it gets compiled, it becomes an SQL, an operation that the database server is going to perform, and it gives you the data that came back from that operation. So, and it does that for JMS as well. It gives you, here's what you put on the JMS queue, here's the response that came back from the server saying, yeah, that JMS message was successfully put on that queue, and if it's got a correlation ID in it, it'll give you all that information back. So it basically, it can help document what's really going on in your systems, which is very cool. There's not a lot of products that can do that level of introspection that CAI can do. But what CAI can also do is it can take all that information because it knows this service called this service using HTTPS on this port, and here's the request that it sent, and here's the response that came back from that. It can actually reach out. If you have Java agents in all of your different servers, they can cascade, and then they'll all report back. Things get chained together, and it bonds all these things together, so you can track complete transactions no matter how many servers they go through during their life, which is pretty incredible. But then you can also since it has all these different layers of this transaction called this transaction made a JDBC operation, this transaction, called this other transaction, which submitted a JMS message and got a response back. It can generate test cases for all of those things dynamically and very accurately. And then those test cases can be run by the test side of the dev test product. Now you're talking completely automated testing with complete test cases that were generated completely automatically from the stuff that's actually running out there in your environment. I don't know of any other product on the planet that can do that, honestly. I mean, there are some things you can do a lot of stuff with Splunk and things like that, but I don't know of any other product that can do the kinds of deep introspection and documentation, complete automated documentation development and delivery in a PDF, and also generating all the test cases that you can drive load through that system to validate that system's working right. It's called Continuous Application Insight, CAI we call it. It used to be called Pathfinder in earlier releases. No. You have it, you just can't use it. The code is installed, it's part of the product.
You have all the stuff, the service virtualization. Right. The picture that showed driving the test and then virtualizing the back end. You get those pieces. Yeah. And CI is just it's additional licensing that's required to actually use that. But it's extremely powerful. I just went about a month ago. I went to a CAI technical training class up in Islandia, where CAI's corporate headquarters is out on Long Island, and I was very, very impressed with what they've done with CAI. It's a pretty amazing product, and I think hopefully you'll hear us talking about it more over time. I think a lot of people have kind of considered it, the postgraduate, level stuff, where unless you've really got your chops around SV, you shouldn't be messing with CAI. But I almost think it's the exact opposite. You can use CAI to document a lot of things that you need to know before you try to figure out what you should be virtualizing or not. I'm just going to add to what you're saying. It's very innovative, and it does. There's more involved. There's more involved, right? Because you're putting agents in different places. It's just more involved. Yeah. With service virtualization, you can find things like I have one.
It's non-invasive, right?
It can be in many instances extremely simple. Yeah. I literally had a customer in the financial services area that had one web service which did date routines, did a lot of date computations. It was actually not financial services, it was actually more insurance services, really, and retirement services. And so when they had to do testing, almost every test had to go through that date web service. And they would have to test things like, okay, what happens when this person's 50 years, or what happens when it's 50 years from today? So they'd have to go into that web service, change that, right? But the other 40 to 50 people that were having to do their testing against it all of a sudden then would get the wrong responses and they would screw everybody else up. So what they were having to do is schedule individuals' time with that web service after hours. And guess what?
It's not a good way to live.
They paid contractors overtime after hours. They calculated, I think they had somewhere between 40 and 50 developers that this was happening to on a regular basis.
Wow.
So not only were they scheduling their time, so they couldn't do their test now when they wanted to, they were having to do it weeks later when it was free after hours. So there was that problem, time to market problem. There was also money problems because they were paying time and a half now only because of that reason. It literally was such a simple virtual service. It took one of his peers less than 5 minutes to create the virtual service. They were able to give it to all the 40 people. They said they calculated in 1 year they were saving $750,000 in overtime fees that they no longer have to. I mean, it's just those little simple business cases that you can find that take.
Yeah,
and that's
everything
why
doesn't have to be,
It's so easy.
virtualizing SAP. They can be little things like that, add up across the enterprise. I didn't even know about that one. That's an amazing story. Wow. Interesting. So, I'm tired of talking. Anybody have any questions?
Questions for these gentlemen? I thought that was pretty cool. I mean, I can see.
It's a pretty cool. I joined CA to support this product. I've been here about a year and a half, and I have a long history. I was with IBM for 20 years working on stuff. So, this is a very, very cool product. I like it a lot. It's fun to work with because you go into an account and they have some thing that you'd never thought of, and it's like, well, can you virtualize this? Sometimes it's a little work, but yeah, 99% of the time we can. So it's pretty cool.
Well, thank you for the presentation and for the pizza and drinks
You bet.
and cookies. Thank you.
He bought them.
All right, well, thank you guys for your time, and I'll hang around for a little bit if anybody wants to chat.
Oh, and don't forget the stickers up here for,
Yeah, I saw these.
for
Those are pretty cool.
DevOps.